Hi folks, Humaira here. If we break down our CO2 emissions worldwide, it is clear that the building and energy are two sectors we need to do better. Nature has been doing development for 3.8 billion years, so let's look at ways nature can help us. We are going to talk about termites, coral reefs, rabbits, and more. Okay, let's get drawing. I started the video talking about carbon emission as a negative thing. Well, they don't have to be. Nature doesn't see carbon as a problem. They see carbon as a building block. Coral reefs are also made of carbon. More precisely, coral's hard exoskeleton is made of calcium carbonate. Corals combine carbon dioxide and mineral in the seawater to make it. Few years ago, a researcher took this recipe to turn carbon dioxide and seawater into calcium carbonate, which is then used to make a concrete. While tons of traditional cement produces about a tons of carbon dioxide, a tons of cement produced with this method sequester half a tons of carbon dioxide, and it takes less energy to make as well. Now, what do you do with this coral cement? We can make buildings. But even after construction, buildings tend to produce a lot of carbon dioxide. Remember our graph from the beginning? 25% of total CO2 emission worldwide are attributed to heat and energy, and residential and commercial buildings are responsible for half of the 25%. Traditional heating, ventilation and cooling, also known as HVAC system, can be very wasteful and burn a lot of fossil fuels. With nearly 60% of building energy consumption allocated to heating and cooling, we definitely need to do better on this. How does nature do this? As it turns out, termites also need to ventilate and control the temperature inside their mound. But they don't use fossil fuels. Inspired by the termite mounds, architect Mick Pierce designed Eastgate, the largest commercial building in Zimbabwe. Like a mound, the Eastgate used thermal mask to store the heat during the day and releases it in the night. The building also has many chimneys and air channels to allow the building to breathe. During the night, the cool air from outside cools down the core of the building. During the day, the large central chimney creates a closed convection cycle, sending the hot air up and out of the building, constantly cooling the core. As a result, the building uses 35% less energy than the other buildings in the same city. This was an example of HVAC for tall buildings. There are solutions all around us. Sometimes we just need to change the way we think about things.